We're going to start with problem number 1. We're going to try to figure out the cash flow, the present value at 18 and 24, 10, 18, and 24%. So these are the 4 cash flows right here for year 1 through year 4, and we're going to solve using 10% right here. So this is the equation right here, 720. If you're using a financial calculator, that's how you would enter this in. Also, we can use it in Excel as well. That's what the problem calls for. Set it up like this: 10, 18, and 24%. And what you're doing is you're going to get a net present value, NPV, and the rate is 10%, and the next function is value. These are the 4 years, and that should give us, you hit OK, there it is, 318805, and that is doing it longhand, if you will, broken out like that. That's the logic behind what we just did right here in Excel. The next problem we're going to have is present value and multiple cash flows. Just like problem number 1, you have a couple different scenarios. One investment is going to pay you $7,300, and another one's going to pay you $5,200. So let's just use a couple of financial functions within Excel to find out what's going to happen. First, I want you to take a quick look at the logic broken out here. The 2 scenarios. Scenario number 1, $5,200 for 8 years, or $7,300 for 5 years. Which of these cash flow streams has the higher present value if the discount rate is 5% and then 15%? So what we do is we go 5% for the $5,200. That is it broken out right here. 5% for the $7,300, and then the 15% for $5,200 and $7,300. Now notice that the present value of the cash flow X has a greater present value at a 5% interest rate, but a lower present value at 15% interest. The reason is that the X has greater total cash flows. At a lower interest rate, the total cash flow is more important since the cost of weighting the interest rate is not as great. At a higher interest rate, Y is more valuable, since it has larger cash flows. At the higher interest rate, these bigger cash flows early are more important since the cost of weighting the interest is so much greater. Now let's look at how you put this together in Excel. Here it is. $5,200 for 8 years, $7,300 for 5 years. Discount rate 5 and 15%. And what we're going to do is we're going to solve a present value. The rate, we're going to use 5%. Number of periods, 8 periods. And the payment is going to be $5,200. $5,200 over 8 years at a 5% discount rate. That's negative $33,608. But if we change this, it becomes a positive. What I did right there was I put a negative sign in there, and that made it a positive number because that's the money coming out to us. That is how to, so you'd want to go through the remaining of those right here, following these steps right here. Number 3 is going to be future value of multiple cash flows. Toadies has identified an investment project with the following cash flows. If the discount rate is 8%, what is the future value of these cash flows in year 4? What is the future value at the discount rate of 11%, at 24%? So what we want to do is take a look at 3. And we are solving for a future value. These are the cash flows each and every year. So to solve this problem, we must find the future value of each cash flow and add them. To find the future value of a lump sum, we use present value, 1 plus the rate over the term. And this is the same thing as finding a present value with multiple cash flows as we did in number 1, except we're trying to solve for a future value. That's the only difference. And as they did right here, future value at 8%, using these cash flows coming in. So what we're going to do is look at how this is done in Excel, and we are going to solve for a future value. Rate, 8%. Number of periods. Now we're trying to solve for the future value of multiple payment streams. And I need to show you a small trick for a moment, and we're going to take a look at this. This is on It's Learning, and this is the Project 1 information we talked about. This is future value of multiple unequal cash flows, just like we're trying to solve for problem number 3. And what you have to do here is this is the outline, this is the problem, and you need to solve these are the answers right here. So we're going to do the first one together. What you're doing is bringing down for each year. We're going to just do one for each year here. Future value, the rate, we're going to use 9%. Now, number of periods, there's 5 years here, and this is the trick I was talking about. It's 5 years, so each year, so for example, if we're doing year 1, and we do 5 minus year 1, that's going to tell the Excel 4 years. The payments, 0, there's no payments involved. Present value is going to be $10,000. Now, to make sure this comes up with a positive number, we're going to enter the present value in as a negative. There we go. And that comes up, 14,115. So we're going to do that for each and every one of these problems. $15,000. Present value, excuse me, future value, rate, 9%. Number of periods, remember 5 minus 2, that takes care of that. There's no payments involved. And present value is a negative 15,000, and we have 19,425. That's how to do that. So then you total those up, and that is going to be the future value of all these payment streams. Now getting back to the project, what we're going to do is we'll do each one together. So we're going to start with future value. The rate is going to be 8%. Number of periods is 4. 4 minus 1. Payments 0. Negative 1375. That's that. Next one. Rate 8%. Number of periods 4 minus 2. And again, there's 4 years. So we're doing 4 minus what year we're working with. Present value goes in as a negative. $17.43. D3. Minus payments 0, present value negative, $6,812. We got it. That's how to do. And then what you're going to do is the same equations, solve for 11% and 24%. And that's how to get that. And I'm going to make one more video showing how to do number 12, and then we'll be done.